Hey, I'm Gagandeep Kaur, a first-year PhD student at WSU, working under the supervision of Dr. Clark. We are here at the Palouse Conservation Field Station today here in Pullman and in the Soil to Society project field trials. We are employing a soil to society approach to track the flow of nutrients from soil to food crops and aim to produce nutrient-dense food in a sustainable manner. Our team oversees rotational and micronutrient trials located in Pullman. And talking a little bit about the environment of the Pullman, Pullman has a Mediterranean climate with dry, warm summers and a mean annual precipitation of around 21 inches. The majority of the precipitation is received between October to April and July to September being the driest months. The soils in the inland Pacific Northwest, they had a neutral soil pH before the intensive agriculture production began in the area. Currently, the soil pH of Pullman soils is around 5, and decreasing soil pH is a major concern for crop production in Washington state. One of the main reasons for decreasing soil pH is the use of ammonium-based fertilizers. The ammonium ions in the fertilizer, they're converted to nitrate ions in soil, and that releases hydrogen ions in the soil that results in the decline in soil pH. Additionally, baling and the removal of wheat straw from field, which is pretty common in eastern Washington, also contributes to pH reduction through the removal of base cations such as calcium and magnesium from soil. And in conventional tillage systems, the mechanical disturbance of soils results in mixing of soil and distribution of hydrogen ions in the soil profile, whereas in case of no-till system, pH stratification has been observed in the surface soils because of the lack of the mixing of soils. We are talking about soil pH because plants require near neutral soil pH as the availability of the essential plant nutrients decreases for pH values away from neutral. Therefore, decreasing soil pH is problematic as it disrupts nutrient cycles in soil, can lead to aluminum toxicity, inhibit plant root growth, negatively impacts nitrogen fixation by legumes in soil, and interrupt growth and activity of soil microorganisms. To combat soil acidification, lime application is recommended. And in this study, we are targeting raising pH to 6 in the liming treatments. Now, talking about tillage practices, conventional tillage involves mechanical disturbance of the soil to prepare for seeding as well as to control weeds and pests. However, conventional tillage is associated with soil degradation as it promotes soil erosion, exposes soil organic matter to decomposition, causes soil compaction, disintegrate soil structure, and can adversely impact soil and crop productivity over time. In contrary, the conservation agriculture tillage practices, they include minimum soil disturbance and promote overall soil health by retaining more water, building soil organic matter, and improving the soil aggregation. The 3 principles of conservation agriculture, they include minimum soil disturbance, crop rotation, and permanent soil cover by crop residues or by growing cover crops. The minimum soil disturbance constitutes direct seeding with no-till practices and controlling weeds with herbicides. Crop rotations, they are helpful to break disease and pest cycles, control weeds, and promote nutrient uptake from different soil layers due to different rooting depths of different plant species. There are additional benefits associated with crop rotation, such as incorporating legumes in crop rotation enhances soil nitrogen fixation. Crop rotations are also recommended for dryland systems to increase crop diversification, which minimizes the fallow period and enhances economic as well as environmental sustainability. Maintaining a permanent soil cover means to keep the soil covered either by retaining residues on the soil surface or by growing cover crops. Maintaining at least more than 30% of crop residues in the field qualifies for the conservation tillage system. Covering soil surface with crop residues prevent water loss by evaporation from soil surface and promotes water infiltration in the soil profile. Soil surface is also protected from erosion when it is covered with the residues. All 3 principles of conservation agriculture are incorporated in the rotational trial. The rotational trial aims to determine the impact of soil and cropping system management on soil health and crop nutrition. We have winter wheat, spring barley, and field peas rotation, and the treatments include conservation tillage versus no-till, lime application versus no lime application, and residue retention versus no residue retention. All the crops, they are represented and rotated through plots in all the years. And in order to determine the nutritional value of crops, we will determine protein content, beta-glucan for barley, and micronutrient composition of grains in addition to crop yield measurements. Talking about the importance of soils, we depend on soils for 95% of our food production, and hence for continual production of healthy food, soil health cannot be overlooked. USDA defines soil health as the continued capacity of soil to function as a vital living source that sustains plants, animals, and humans. For soil health analysis, we'll be measuring physical, chemical, and biological properties of soil that include soil bulk density, wet aggregate stability, saturated hydraulic conductivity, soil pH, soil fertility profile, fractions of carbon in soil, and enzyme analysis. These parameters are indicative of water storage and transport through soil, dynamics of soil organic matter, plant nutrient availability, susceptibility of soils to erosion and runoff, crop productivity potential, and can overall impact crop yields. The preliminary results from this rotational trial suggest no significant difference in yield and protein content between the treatments. It may be because the management practices, they are seen to show differences over longer span of time, and since it's a 5-year project and we are in the second year of project, we hope to see significant differences between the treatments in the coming years. Here we are here in the micronutrient trial that is a part of Soil to Society project research trials, and this experiment is located in Pullman this year and will be moving to Reardon for the next year. The main objective of the micronutrient trial is to determine the impact of micronutrient fertilizer application timing on crop yield and grain micronutrient composition. Micronutrients, they are crucial for optimum plant growth as well as an important constituent of human diet. Iron, for example, is crucial for symbiotic nitrogen fixation, respiration, and photosynthesis in plants. Zinc deficiency is commonly observed in plants and can drastically impact grain nutrient content. Micronutrient deficiencies in plants can hold back the productivity potential and can result in crop yields. This trial, micronutrient trial here, includes 3 winter wheat varieties, that is Norwest Duet, LCS Shine, and Pearl, with treatment constituting no micronutrient fertilizer application, micronutrient soil applied at planting, foliar application of micronutrients at top dress in early spring, and micronutrients applied at heading. For this experiment, we will determine crop yield, grain protein content, and grain zinc, iron, and manganese content.